All right, we're starting our calculus year with the idea of limits, and limit, all it really means is just a value that the graph of a function approaches at a point. The way we write it here, this lim means the limit, x arrow 0, that means as x approaches 0, and this can be any number, 0 is just one we use most often, of f of x. So we read the limit as x approaches 0 of f of x equals some number. So the easiest way to look at this is here's x equals 0, and here's the graph, right at this point right here. What y value is the graph approaching at that point? And the answer to that here is the y value equals 1. So that's why the limit is just 1. Now, something to look at here. In this function, if I want to know what is, for example, f of 1. Well, f of 1, we should know whether by looking at the graph or by looking at the function does not exist. I'd be dividing by 0, so it can't possibly exist, and there's a hole in the graph. So the function itself does not exist. However, we can use limits to help kind of say, well, what would the limit, or what would the function value essentially be at that point if the function did exist? So what I mean by that is, as I'm approaching x equals 1, what is the y value that looks like it should be getting hit? Well, that y value is 1, 2, 3. So the limit is 3. Even though the function doesn't exist, we can still look at it with a limit. Another thing we can do, if I have, say, this function right here, and I'm going to pull it up on the calculator for you to see. So here it is. If I hit the graph function, what I want to look at with that function is I shouldn't be able to divide by 0, which means if I plugged in, well, 0 in the bottom here, I should have a function value that doesn't exist. And look, it doesn't. But however, I can look at the graph and say, well, it looks like that's about at a y value of 2. So it should look like the limit is close to 2. Now I can tell for sure by hitting the left and right arrows here, looks like as I get closer and closer to it, my y value is getting close to 2, and on the left side it's just a little bit less than 2. So either way I'm approaching 2, and that's why if I look at that, my limit there is exactly that. It is 2. So if I wanted the limit as x approaches 2, or I'm sorry, 0 of that function, it is just 2, even though really f of 0 does not exist. Now I can find limits of any number. If I want to know the limit here as x approached, let's say 8, let me go back to that real quick. If I punched in 8 for this, well, it has a y value of 4, and I'm approaching it from that side, from both ways. So the limit of that would just be 4. So if the function value exists there, that just makes it nice and easy that the function value itself is just what the limit is. But in this case, even though the function didn't exist, I still could have a limit. That's what we're talking about here. Now, a couple other examples. Here's a function and its graph. things I can look for. F of 0, well, that's part of this part of the piecewise function, so the function is 1. The limit as I approach 0. So here's 0. What y value am I approaching? It is just 1, just like we thought. Now this one, f of 2. Well, here's where x equals 2, so the function value is 0. Now what number am I approaching, though, as I come towards x equals 2? Well, it is the y value of 1. So in this case, the limit and the function value are not the same. We have a little discontinuity happening here, and we'll talk more about that down the road. Here's another piecewise example. Let's start here with f of 5. F of 5 would be over here somewhere. And if we looked at it this way, 5 is greater than 0, so I should be looking at this part of my function. So it should be the function is negative 2. What's the limit? Well, as I approach it, here's 5. What am I approaching? What y value? I'm approaching exactly that. I'm approaching 2. Now, f of 0. That also comes in the bottom part here, so it is still, the function is negative 2. Now, what is the limit as I approach 0? Well, as I approach 0 from this side, I'm approaching 2. If I approach it from this side, well, I'm approaching a y value of negative 2. So is it 2 or is it negative 2? Which one is it? Well, if it's not the same from both the left and the right, then it can't be either. Then we're going to say this limit does not exist. The limit from the left must equal the limit from the right. These are called one-sided limits. And the best way I can explain it is, say you have, two long-lost lovers that are coming towards each other. But this guy is going to positive 2, and the young lady maybe is going to -2, for example, well, guess what? They're not going to the same place. They're never going to be able to fall in love. Therefore, their love doesn't exist. The limit does not exist. That's the way I would try to explain it there. Now, here's a way we can write a one-sided limit and what these mean. All these are, it's coming from both directions. These are from one side. So for this first one, it's the same exact thing as we wrote here, except this little negative sign. All that means is I'm only looking from the left, only from the negative way. So only this part right here. So as I'm approaching from the left, what number am I approaching? Well, that's a +2, looking just from the left. When I go from the right, the positive, I'm approaching, in this case, a -2. And notice, the limit from the left does not equal the limit from the right. That's why the limit does not exist. So I would even write that the limit does not exist. We can say because the limit as you approach x from the negative is not the same, does not equal the limit as you approach x from the positive. And that's all we need to look at in terms of looking at limits based on their graphs.